Okay, in this session we will see a small Proteus 8 simulation procedure for the PIC 18F877A microcontroller unit with the LCD display device. So as we know, on the right side of this presentation we can see the liquid crystal display having the data lines from D0, D1, D2, D3, D4, D5, D6, D7. All these are data lines of the liquid crystal display, and on the left end we have an VSS ground, VDD power supply, VWE for the contrast, and then read or register select, and then register write, and then enable pin. On the left side of this presentation we have the PIC 18F877A. It is an PIC microcontroller. It has the ports from RA A port, on the right B port, and then C and D. So these lines are connected with the LCD display. As we start with the data lines D4, D5, D6 and D7, all these lines are connected with the B ports, and then we have a VSS ground. It is connected to the ground level. VDD is supplied to the 5V pin, and then VWE is also connected to the resistor to vary the contrast or brightness of the LCD display. And then we have a register or read pin. Read pin is connected with the pin number 37. It's called as the B port 4. Likewise, the write pin is connected with your signals. And then to simulate this particular Proteus, we need a embedded C program. That embedded C program can be discussed or compiled in another simulation tool which is called as the micro C for PIC. So this is the embedded system or embedded C code for the PIC microcontroller unit to interface with the LCD display. Let us start with the enabling the LCD display unit. We have the LCD read pin. It is here the S bit. S represents set bit. See, for the register or for the LCD underscore read pin is connected at the port number 4 of B port. Likewise, remaining the enable pin to the 5th pin of the B port, following by D4. Data lines of D4, D5, D6 and D7 are connected with the RB0, RB1, RB2, RB3 bits. These are the lines for the LCD enable connections. At the same time, the direction is based on the register. That's called trace register. So bit we enabled, and then we have to go for the module connections by using the trace registers. So when you have a direction, as usual, similar to the bit configurations, we have a trace bit registers, trace B4, trace B5. For the data lines we have B0, B1, B2 and B3, and then we initialize the character I for the using the for loop, For the LCD display, we should initialize the LCD by using the inbuilt functions called as LCD underscore initialize, and to clear the data in the LCD to provide a LCD command, and to make the cursor in the first position of your data, we call the function called LCD cursor off. And finally, we provide the data across your LCD by using the whatever the data we can provide across this double quotations LCD out. In the row 1 and column 1, the data is supposed to be mentioned in the double quotations. Then we call with the repeated mode of information of the display device across LCD. Here we are using a for loop. We are representing the initializing the for loop and then condition for the for loop and incrementing, where we can represent the data has to be moved from left to right, or right to left, or top to bottom, or bottom to top by using the command called underscore LCD shift underscore left. We provide the delay as 300 milliseconds.